Hello guys, we are on 2.1. 2.1, this is solve for x, okay? We are having 2.1.1 like that, okay? Let's give it a try. We are having 2.1 like that, then we are told that we should solve for x, okay? We are having this equation there, okay? When you're checking our equation there, we are having x and x, okay? It means x is a common factor. It appears here and it appears there, okay? Then you're going to take x out. That's a common factor, okay? Then you're going to have x into, when you take out x here, you remain with p, okay? When you take out x here, you remain with q. Then you're having something of that magnitude, okay? Remember, you want to remain with x, okay? Then when you want this bracket to disappear, okay, then you divide by it, okay? You divide by it both sides, okay? Then you're going to have p plus q there, okay? This bracket dividing that bracket, okay, you remain with 1, then 1 multiplying x, we have x, okay? Then you have a dividing the p plus q, okay? Now you remove this bracket, they no longer serve a purpose, okay? You're having it like that, okay? If you're having any question, you can ask. Let's go to the second one. 2.1.2. We're having 2x squared subtracting the 5x there plus 2, okay? We are also still expected to solve for x, okay? We are having x here, we are having x here, we are not having x there, okay? It means you cannot take out the common factor, okay? And we are having x as the second degree there, okay? It means here we need two binomials, okay, multiplying each other, okay? We factorize, okay? Then whatever sits here and there should give us 2x squared, okay? We must have x and x there. X multiplying x is going to give us x squared, okay? Then we need to look for factors of 2, okay? We are having 1 and 2. Then here we can have 2 and here we can have 1, okay? There's no need for us to write 1 there, okay? With the middle term, we need 5 there, okay? Then here we are going to look for factors of 2. Obviously, we know that factors of 2 are 1 and 2, okay? Then it's either 1 can sit there or 2 can sit there, okay? But remember, on the middle, we need what? We need 5, okay? If we got 1 here and 2 here, okay? We're going to have this 2x multiplying 1 here, then we're going to have 2, okay? Then this 2 is going to multiply x there, then we're going to have 2x, okay? Then 2x plus 2x, they don't give us a 5, okay? Then it means 2 here is a better idea. We need to swap them, okay? We need to swap them there, okay? Then it means here we need to swap them. Then we need to try 2 this side and 1 that side, okay? Then we're going to have 2 multiplying the 2 there. Then we got 4x, 1 multiplying x there, then we got x, okay? 4x plus x, it gives us 5x, okay? But since here we need negative, then it means here we must have negative and negative, okay? Negative 4x subtracting x, we are going to have negative 5x, okay? Then it means here our 2 should be negative, because 2 multiplied by negative 2, you're going to get negative 4, okay? Then it means even here we should have negative 1 multiplying x, there we're going to have negative x, and negative 2 multiplied by negative 2, we're going to have positive 2, okay? Then it means we have factorized it correctly there, okay? Then now we need to continue, okay? Since we are having 2 brackets multiplying there, and here we are having 0, then this bracket equals to 0, that one equals to 0, okay? Then we can have 2x subtracting 1 equals to 0, or x subtracting 2 equals to 0, okay? Then here we take 1 to the other side, we're going to have 2x being equal to 1, then we divide by 2, then our x equals to 1 over 2. Then even this side, we're going to take this 2 to the other side, then you're going to have x equals to 2, okay? We're having it like that, okay? We're having our x as 1 over 2, or our x as 2 there, okay? We're having it like that, okay? Then with this one, we should not get it wrong, okay? We can take one of the values there and plug it here on the original equation, then we should get 0, okay? Let's prove it. We're going to have 2, let's use 2, let's use x as our 2, okay? Where we see x, we substitute 2, then I'm going to have 2 squared there, subtracting 5 into 2 there, okay? Then plus 2, then we're going to have 0, then we're having 0 there, okay? Then it means our x values are correct, okay? You can even plug this one, you should get the 0 there, okay? We are having it like that, okay? Then we have the last one here. We have the last one here too. We have 2.1.3, okay? We are given something of this magnitude 1 over 2 to the exponent 3x plus 1 there being equal to 32, okay? And still we're expected to solve for x there, okay? With this one, we should start by expressing 32, okay? We go to our calculator, say 32 equals to, then we say shift fact, then we got the 2 to the exponent 5s for the 32 there, okay? Then this side we're going to have 1 over 2 to the exponent 3x plus 1 here, having 2 to the exponent 2 to the exponent 5 there, okay? Remember, we got this law says that if you are having the same basis, we can equate the exponent. But when you look here, we're having 1 over 2, then here we're having 2. These bases are not the same, okay? But when we come to the 2 there, we remember that the 1 over was used to run away from negative exponent, okay? Then we can bring back the negative exponent, then we can express 1 over 2 as 2 to the exponent negative. This negative was taken care of by the 1 over, okay? Then the exponent that we're having here is 1, then we should have 1 there, okay? Then we're still having the outer exponent there, okay? Then we are still having the 2 to the exponent 5 that side, okay? Then we can take this remember, if you press 2 to the exponent negative 1 on your calculator, you must get 1 over 2, okay? Then now we can take this negative and multiply it there, okay? Then we're going to have 2, then negative 1 multiplying 3x there, we're going to get negative 3x, negative 1 multiplying positive 1, then we get negative 1. Then this side we're still having 2 to the exponent 5 there, okay? Then we're having it like that. The bases are the same now, okay? We're having 2, we're having 2, now we equate the exponents. Then we're going to have negative 3 subtracting 1 equals to 5 there, okay? Then we solve for x, okay? Then we solve for x means we must take this one to the other side. We're going to have negative 3x equals to 5 plus 1. Then negative 3x equals to 6. Then we divide by negative 3. We divide by negative 3. Our x is equals to negative 2. Then we are having it like that, okay? Then even with this one, we should go back to our original question where we see x, we should substitute by negative 2 and see if we get 32, okay? We're going to have 1 over 2 there to the exponent 3 into negative 2 plus 1. We should get 32. Indeed, we get 32, okay? Then it means we have solved for x correctly here, okay? The only problem was to change 1 over 2 into 2 to the exponent negative 1, okay? So that the basis can be the same. That was the challenge. Bye.